In this video, we're going to look at more difficult examples of fundamental theorem of calculus. Differentiation and integration are inverse processes. FTC gives the relationship between these two processes in terms of a formula. Theorem: let f of t be continuous on a closed interval ab. If c is any number in the interval ab, then the derivative d dx integral c to x f of t dt is equal to f of x. We've looked at this theorem before. Let's apply this theorem. Find the derivative of g of x is equal to x to 1, third root of 1 plus t dt. We notice that f of t, the integrand, which is third root of 1 plus t, is continuous on the entire real line, minus infinity to infinity. So we can apply the fundamental theorem of calculus. Apply FTC. Now we have g of x is equal to integral x to 1 third root of 1 plus t dt. Before we can apply this formula, the upper limit should be the variable x. So we need to interchange the upper and lower limits. So let's do that. G of x. And when we interchange the upper and lower limits, we need to put a negative in the front. Negative 1 to x, third root, 1 plus t dt. Now let's apply FTC. G prime of x is equal to minus d dx from 1 to x, third root, 1 plus t dt. Derivative cancels the integral out, and this x goes inside, gets substituted for t. So we get minus third root of 1 plus x. That's the answer, g prime of x. All right, let's extend this theorem to handle more difficult cases where the upper limit is a function of x. Let f of t be continuous on a closed interval ab, and if c is any number, any real number between a to b, then the derivative d dx of the integral c to g of x f of t dt is equal to f of g of x times g prime of x. So basically the upper limit, which is g of x, is a function of x. We substitute that for t, then we multiply by the derivative of that upper limit. Derivative cancels the integral, substitute the upper limit g of x for t, and multiply by the derivative of the upper limit. Let's prove that using the chain rule. All right, so let y be equal to d dx integral c to g of x f of t dt. Dy dx by the chain rule is going to be d du, derivative with respect to u, integral from c to u, f of t dt, times du dx. That's applying the chain rule. Now, by the fundamental theorem of calculus, derivative cancels the integral, and the upper limit, which is u, goes inside for t. We get f of u multiplied by du dx. But we know that u is equal to g of x. That's the upper limit, that's a function of x. And du dx, the derivative of u with respect to x, is g prime of x. So let's rewrite dy dx is equal to f of u, and u is equal to g of x. Let's substitute that in, times du dx, that's g prime of x. So we've just proven that d dx of the integral c to g of x f of t dt is equal to f of g of x times g prime of x. Let me clean this up and rewrite it, g prime of x. All right, so now let's look at an application of that. So find the derivative of h of x is equal to integral from 1 to x to the fourth root of 1 plus t squared dt. The first thing you notice is that the upper limit is a function of x. That means we have to apply the chain rule. Root of 1 plus t squared is continuous on minus infinity to infinity. So we can apply FTC. And so h prime of x is going to be d dx of the integral 1 to x to the fourth root of 1 plus t squared dt. By the formula above, derivative cancels the integral. The upper limit, which is x to the fourth, is substituted for t, and you multiply by the derivative of that upper limit. So h prime of x is going to be equal to root of 1 plus x to the fourth, substituting the upper limit for t, and squared, multiplied by the derivative of x to the fourth, that is 4x cubed. Let me write this in. d dx of x to the fourth using the power rule, that is 4x cubed. Let's simplify this. H prime of x is equal to root of 1 plus x to the 8 times 4x cubed. That is the derivative of h of x. All right, let's do a bit of review. So assume that f of t is continuous on a closed interval a, b. Number 1, integral from a to b, f of t dt. This is fundamental theorem of calculus. This is going to be capital F of t, which is the antiderivative of the integrand, antiderivative of f of t, evaluated from a to b. That's equal to f of b minus f of a. Antiderivative of b minus antiderivative of a. Number 2, derivative d dx of the integral from c to x, f of t dt. Derivative cancels the integral, and we get f of x. Number 3, d dx of the integral from c to g of x, f of t dt. Here we have to apply the fundamental theorem of calculus as well as the chain rule because the upper limit g of x is a function of x. Alright, so we get f of g of x, substituting g of x into t, and multiply, don't forget to multiply by the derivative of the upper limit, multiply by g prime of x. Alright, thanks.